Hi, welcome to Physics with Ben. Don't forget to subscribe, like, comment, and share this video to those that need it. In today's video, I want to make the video you guys have asked me to make. You guys have pressured me so much to make a video on WAEC 2024, Physics 3, question number 3, alternative B, mechanics. This is the question. It will interest you to know that this question came up in WAEC 2021. I am a WAEC examiner, so when we go for WAEC coordination, we have access to the questions so that we can mark. So I would love to show you this question, just so you can see this. This is that year's WAEC 2021 experiment. I told you I am a WAEC examiner, and when you go for coordination, you have access to this. That is why I have a copy of this with me. So this is the question here. This was the experimental setup. The question came and they asked us a lot of questions on that day. And we were wondering how it will look like. And by the end of the day, this was what we had. Now, this year they asked us to provide this guide. The two rotor stand. The two rotor stands were demanded. Masking tape was demanded. A thread, masses, and 2-meter rules. Now, looking at everything, I was inspired to predict as follows. This year, this stuff may not be available, but we are going to predicting what may happen, that tomorrow it is possible that you are going to fasten this mass to this and then hang it here and then oscillate it horizontal oscillation. It will oscillate like this. That is how it oscillates. So right now I'm going to do the experimental setup, and I will draw the table of values for you, and I will just run one of the values to guide you on how to go about it. Good. The next thing I will be doing is that I'm going to teach you some basic theories behind the experiment. That is to say, the equations controlling the experiment. Don't forget, they also asked us to use a stopwatch. So based on all of these materials needed and demanded, this is how the experimental setup may look like. Disclaimer, this is not exactly how the questions will look, but something close to this. My channel does not promote examination malpractice. Read your books, watch my videos, play your part, and pray to God, and then success becomes inevitable. Without me wasting much channel, I'll go straight to the business of the day. So this is the rotor stand. This is one rotor stand, another rotor stand, and this is the rope that we are looking for. Twine, the black twine. It looks very strong, you cannot cut, because masses, the weight of this will be hanging on it, and other masses will be dangling on it. So if you are using the thread, if you are using the other thread that the tailors use, you may experience accidents, or you may experience difficulty along the experiment, because the rope may snap and everything will collapse and fall down. So I advise you to look for this guy so that you use this guy. So the thread has been fixed to the rotor stand here. This is how you are going to fix it. The thread will run down with a rope. This is a loop here. You can see what I'm doing. This is a loop. You can take it down and take it up. So another rope here, another loop here that you can easily loosen and also tighten again. So this is a loop. See that? You can see that. Something like this. This is what you are going to make. So the next thing is in that experiment, as you can see in this diagram, you can screenshot this. I don't have time to read and read. So screenshot, this is what you have in 2021. But this part will not be in this experiment. This part, I suspect, will not be part of it. Good. Yeah, that is all. So what we're going to do is that we're asked to, in that experiment, My student did it and they got clear results. We're asked to put this 10 cm from the origin, or let's say 5 cm. 5 cm from the origin. That is at the 5th cm mark. They may ask you at the 10th cm mark. So just watch what I'm doing. And this on the 95 cm mark. That was what we did the other time, if I still remember. They may ask you to place it any side, any place. So this is the 95 cm mark. And then the next thing you have to do is that you have to shift this so that, and shift this side so that this aligns, so that you don't have something like this. This is not acceptable. You can't have the rope going this way. You can't have it either going this way. You can't have a V shape like this. So everything must be vertically straight down. So you take it this way, and ensure that they are vertically straight down. And then the next thing is that the length of this rope on this side must be the same with the other rope. And that's the reason why they ask you for this ruler. So you shift this to this side, you shift it outside, and then I look for 2 of this. Why am I using this? So that along the line I have a balanced force. If you add this to it, it will be very, very heavy, and if you are not careful, this guy may fall out. So this is how you set it up. And then the next thing is that we were asked in that experiment to measure the length. So this is on the 95 cm mark, and this is on the 5th cm mark. So the next thing is to find your 0 will be on the top and the other one down. So from this point, let's measure 70. So this is 70 centimeter. This is 70. Bring it close. This is 70. You can see that. Good. So I'll also measure 70 on this side. A very, very, very simple experiment. Good. So this was the experimental setup. So I'm going to push this to come out a little bit. Good. It is good now. We are good to go. So what will happen is that this experiment is performed under the topic called simple harmonic motion. We can perform simple harmonic motion using the simple pendulum. It will swing this way and swing this way. That is one oscillation. We can perform simple harmonic motion using the spiral spring. That is Hooke's law. I have all the videos on the channel. Just click them and see it. Another one is that we may tighten this guy here and put a mass here and something like this. I have a video on this as well. I also have a video on vibration, on vertical vibration like this. It is also simple harmonic. Another one on this, where the masses are here, you oscillate it, it goes up and down and then it vibrates. That is also simple harmonic. We also use a simple pendulum. That is also simple harmonic. Then the 4th one is the bifilar experiment. This one, if you can resolve to hang masses down or fasten the masses at the middle here. So this is what will happen. Our table of values will be displayed. Our table of values will be displayed shortly, and you will know how to go about it. So in this experiment, they are going to vary the length of the thread. Maybe they will start with 100, 100, 100. And then they may ask you to measure the distance between these two loops. And this distance will be constant. Maybe D, capital letter D or small d. And that's the distance between this loop. And then the length of the thread may be 100 centimeter, 80, 90, 100, 90, 80, 70, 60, 50, and 40 centimeter. And it will interest you to know that the length of this thread is directly proportional to the period of oscillation of this setup. That is to say, increase in the length will cause increase in the period of oscillation. That is the relationship. So you're going to be having an increase or a decrease trend. So without wasting more time, let me start it off with what I have here. So I'm going to generate the table of values and then we'll run the experiments. Yeah, welcome back. This is how your table of values may look like. Now I forgot something. They said and other necessary materials, meaning they will also ask you to bring some materials under there, and some of those materials could be the weighing balance. The weighing balance may be used to weigh the mass of the ruler that you are using. That year 2021, when we run the experiment, this guy was asked. So the mass of the ruler that we used on that day was 171 gram, and today the mass is still the same thing. So mass of the ruler is a constant for that particular ruler throughout the experiment. And the distance between the two loops, that year it was 80. It was 10 this side and 90 this side. This loop were placed on 10 cm and were placed on 90 cm. So the distance between the two of the loops were 80. So I don't know what the distance may look like. That is why I'm saying disclaimer. This is not exactly how your exams will look like. So I want to predict that this is how it will look like. So the distance between the two loops is a constant, and you have to record all the constants on top of the table of values. They asked us to use 20 oscillations. That is going this way and coming this way. That is 1, 2, 3, 4, 5, up to 20. That is 20 oscillations. So I still wrote 20 oscillations here. So 20 oscillations is a constant for this particular setup. And then, I don't know, they may ask us to vary the length of the thread. If they ask us to vary the length of the thread, then this column will be valid. This column will be valid. But if the length of the thread, which is 70 will be constant throughout the experiment, then this column will be out of your table of values. However, they will vary the length, the masses or the length of the thread. They may vary them simultaneously, or they may tell you to perform it and then have a composite table at the end of the day. Maybe one table where you have to vary the length of the thread, just like what we did in electricity alternative A question number 3. 2 wires, wire A and wire B. So here they may ask you to vary the length of the thread. Another one, vary the masses, and then they may plot the graph of mass against length or length against mass. I don't know how it will look like. But this is a setup, so you can perform it at home. For the sake of this experiment, I'm going to vary the masses. Don't forget, I told us that the length of the thread is directly proportional to the period of oscillation. Increase in the length of the thread will cause increase in the period of oscillation. So let's start with the first mass. So this is 50 grams. So we record. They may bring smaller masses. So this is just for the sake of the experiment. So we start with 50.00, and then you go with another 50, that is 100.00. Then you go with 150.00. Then you go with 200.00. Then you go with 250.00. They may bring smaller masses, maybe 10, 20, 30, 40. But this is how it will look like. And then The first setup will look like this. They may ask us to fasten this mask. This is the masking tape. This is the tape, the paper tape that they ask us to use. So the paper tape we use to fasten this mask at the middle of the ruler so that it does not fly off while performing the experiment. That is the reason for this tape. The paper tape is to fasten this mask here at the center so that it does not fly off. So at this stage, I think we are good to go. Another thing is that you have to, your rotor stand needs to be strong, needs to be clamped very firm so that the masses does not slide. So I want to be sure that this is all still 70 cm. So this, you see, this is more than, this is this is 20, this is 0. You see, this is more than 70 now. So these are the things that you need to check tomorrow. So I will take this stuff up and then tighten it up here, very strong. So this is I'll still take it up. This experiment should be performed by 2 students. It is not a 1-student experiment. And then when they are done, they will separate ways. The only thing that connects them is the experiment. Once they are done with the table of values, they should separate. Good. So this is so I will tighten it here so that it does not slag again. And I also test it from this side to be sure that it is 70 cm. Yes, it is still 70. Good. So I am done with that. So I will tighten it here so that it does not slap. Let me still verify that. We are doing all of this to avoid error due to parallax, and that is one of your precautions. That is 70. So at this stage, we are set to perform the experiment. So we are going to, this is our stopwatch. It is not like this. It is like this. So as if you want to open the tap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I got 19.313 seconds. So I will record 19.13. I have to take another value again and then find my T average. That's very, very important. Because the number of oscillation is 20. It's not up to 30. So you're going to have error if you don't repeat it. So I'm going to reset my stopwatch. So let's run it for the second time to find our T average. So as if I want to open the tap in the anti-clockwise direction. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This time I got 18.94. So I'll record 18.94. I am done with that particular experiment. I can find this later. Let me proceed to add another mass to discover the trend of the experiment. So this time we are doing for 100. So 50 plus 50 gives us 100. So this is 100 gram. So I will fasten it here. Very, very simple experiment. Good. So we want to assume that the examiners, we want the length of the thread to be constant. That is 70-70 throughout the experiment. 70-70 throughout the experiment. So I still want to check if this thing is still 70 so that I don't make mistake. It is still 70. Please, this thing I'm doing is very, very, very important. It is still 70. You can see that, still 70. Just take it up a little bit. Still 70. Good. So let's run this experiment. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 17.34. Let's take that again. Let's take that again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got 17.53. Okay, let's go for 15. It seems we're having a decrease in period of oscillation here. Increase in mass. I will verify that later. I will confirm how true that is through an equation. So this is 150. So let's see what we're going to have for 150. This is the use of the paper tip. Good. So we are done with the experiment, and this is the table of values I discovered. One thing I observed with the last value was that this guy tried to topple up like this. So I'm suspecting they may hang, they may put a rope here or hang this stuff down as they did last year to avoid unstable equilibrium, so that the weight goes down but not up. So that was what I observed. The last value, this tried to topple up when I was trying to oscillate it. It tried to something like that. Good. So they may put the masses down. That is one thing I observed. So you can try that at home. So this is a table of values. I observed that as the masses were decreasing down, the time of oscillation was decreasing down. So this value is gotten by this plus this divided by 2, we got this. And this table, this column, we got it time divided by number of oscillation. So this divided by 20, we got this column. And then this square, we got this. And one divided by everything here, we got this. So this is a table of values. They may ask you to plot the graph of mass against period, or period square against mass. Any one that comes will be fine. So like for this year, it was a graph of t square inverse against n. So it could be a graph of this against this, or this against this. Anyhow it comes, let's have to go about it. Finally, we want to, so this is an increase decrease trend, and for this you have increase. So this is increase. So it could be the mass, the graph of this, just like what they did here, graph of t square against m M inverse, against M. So T square inverse is an increased trend and M is an increased trend. So it could be, the graph will be this against this, that is increase. And as I will always predict, such a graph will be this graph, or this graph, or this graph. Any of this graph could be a graph that you're going to get. 1, 2, 3, any of the graph. So the next thing I want us to call our attention to is the equations for the experiment. This is simple harmonic motion. They will surely ask you, they may ask you to define simple harmonic motion. They may ask you to define period of oscillation, that is in BI and the BII part of the experiment. They may ask you to define time, period of oscillation, or frequency of oscillation. So these are the basic equations that you need. T is equal to 2 pi root L all over G. The length of the thread, that is equation 1, very basic equation. We also have omega, angular velocity, equals to 2 pi F. You also have omega is equal to 2 pi over T. All the equations under simple harmonic motion, go and revisit them. So these are the equations that may be used in the experiment. To this, I hope I have come to the end of this experiment. Click in the description box below. You'll see the video link on on electricity and optics. And this is how far I can go about mechanics. You may watch other YouTube channel and get more information adding to this. There's stuff I cannot say here, but others may say it. And then I don't know to all. I'm not an ITK. This is how far I can go about this experiment. I have come to the end of this experiment, and I wish you guys success on through. Don't cheat. Read your books. Pray.